In last lecture, we have discussed about the gamma function, any particular type of the definite integral. We defined that one and also define the recursion formula and particular value of the gamma function at 1 by 2. These things we have discussed in the last lecture. The next in today we should discuss some another particular type of the definite integral, which is named as a beta function, which is named as beta function. Beta function. What about it? How to define it? If mn are positive, then the definite integral 0 to 1 x raised to the power m minus 1 into 1 minus x raised to the power n minus 1 dx, which is a function of m and n after integration, is called the beta function. Is called the beta function, or alternate name for this one is Euclidean integral of first kind. Our gamma function is a Euclidean integral of second kind and beta function is a Euclidean integral of first kind, and is denoted by this b of mn. Thus, therefore, any beta mn is equal to b integration 0 to 1 x raised to the power m minus 1 into 1 minus x raised to the power n minus 1 dx for mn both positive. For mn both positive. This is the definition for the beta function. Now let us discuss some properties of the beta function. That the first one is symmetry of the beta function. Symmetry of beta function. That is, and a beta of mn is equal to the beta of nn. This is to prove by the using the definition. Since by definition beta mn is equal to integration 0 to 1 x raised to the power m minus 1 1 minus x raised to the power n minus 1 dx for mn both positive. Also, since as per the some property of the definite integral, this property of the definite integral, and integration 0 to a f of x dx is equal to be integration 0 to a f of a minus x dx. Using this property, the above definition beta mn and above definite integral will become 0 to 1 f of, replace f of a minus x. Here a is 1. That means replace x with 1 minus x. That is 1 minus x raised to the power m minus 1 and 1 minus of 1 minus x raised to the power n minus 1 dx. That is equal to be simply, that is 1 cancel with the 1 in the second bracket and remaining only the term x raised to the power n minus 1 and then 1 minus x raised to the power m minus 1 dx, which become the definition for the beta nm. Hence, this beta function is symmetric, and a beta mn is equal to be beta nm. This is about the symmetry of the beta function. Now we would like to define a relation, an important relation between beta and gamma function. Using that relation, some of the integral which are very difficult to integrate, difficult to evaluate, we can evaluate easily. That is the relation between beta and gamma function. That is, the relation is defined as, which is to be proved, beta mn is equal to be gamma of m into gamma of n divided by gamma of m plus n. This is the relation which is required to be proved. Proof. Since, yeah, as we know that gamma of m is equal to be integration 0 to infinity e raised to the power minus t raised to the power m minus 1 dt. Now let t is equal to be x square, t is equal to be s square, implies dt is equal to be 2x dx. Therefore, the above gamma function will become gamma of m is equal to be twice, limit will be the same, e raised to the power minus x square, and t replaced with x square, that means x raised to the power 2m minus 2 into, for 1x is from the 2m minus 2 into x dx. That is equal to be twice of integration 0 to infinity e raised to power minus x square into x raised to power 2m minus 1 dx. It will become this one. This is in terms of the gamma of m in terms of x. As we know that in definite integral, variable doesn't matter. So one can write the gamma of n similarly, gamma of n is equal to be twice of 0 to infinity e raised to the power minus y square into y raised to the power 2n minus 1 dy. 2m minus 1. Then using the in the proof of gamma, in the proof of value of gamma 1 by 2, we use to multiply two integral that will convert to be double integral by using some properties of the double integral. The same property will apply here also, that is multiplying 1 and 2, multiplying 1 and 2, we get gamma of m into gamma of n is equal to be 4 times of 0 to infinity e raised to power minus x square x raised to power 2m minus 1 dx into integration 0 to infinity e raised to power minus y square y raised to power 2n minus 1 dy. Then it will convert it to these product of these two integral, wherever limits are constant, integrand are variables are independent to others, so they converted to be double integral. Integration 0 to infinity e raised to power minus times of x square plus y square into x raised to power 2m minus 1 into y raised to power 2n minus 1 dx dy. Then change into the polar coordinate. To solve this integral, we have to change into the polar coordinates, that is x is equal to be r cos theta, y is equal to be r sin theta, and r varies from, because the above integral, since the above integral, the above integral is in the positive quadrant, so r varies from r varies from 0 to infinity, and theta varies from 0 to pi by 2. 0 to pi by 2. So we have the above integral, that is gamma of m into gamma of n is equal to be 4 times of integral 0 to pi by 2 integral 0 to infinity e raised to power minus r square, x is equal to be r cos theta, that is r cos theta raised to the power 2m minus 1, y is equal to be r sin theta, raised to power 2n minus 1, and corresponding dx dy will become r dr d theta, r dr d theta. Then just simplify it, that is equal to be 4 times of integration 0 to pi by 2 0 to infinity e raised to power minus r square, combine the similar power of r, that is r raised to the power 2m and 2 twice of m plus n and minus 1, because we have minus 1, it will become minus 2, but we one more power as a plus 1, that is plus 1 cancel with 1 minus 1, and only remaining is minus 1. Power of r is remaining as minus 1 into cos of 2m raised to the power minus 1 theta into sine of 2n minus 1 raised to the power theta into dr d theta. Then because r and theta are totally independent, we can convert again this double integral into the product of two integral. One is this e raised to the power minus r square, r raised to the power 2m plus n minus 1, integrate with respect to r, and another integral will become 0 to pi by 2 cos raised to the power 2m minus 1 theta into sine raised to the power 2n minus 1 theta d theta. As per the definition of the gamma function, the first part of the since twice of 0 to infinity e raised to the power minus r square into r raised to the power 2 m plus n minus 1 dr will become gamma of m plus n using 1 or 2, using 1 or 2. Since we should write, not since, now, and putting and putting sine square theta is equal to b. We have already t as considered. Z implies 2 sine theta cos theta d theta will become dz, and cos square theta will become 1 minus sine square theta, that will become 1 minus z square. 1 minus z, sorry. 1 minus z, because sine square theta consider as a z, that is 1 minus z. Means if we have the power of cos raised to the power m minus 1, that means this implies cos. So you can consider the above integral. Therefore, twice of the second integral in this part, twice of integration pi by 2, 0 to pi by 2, cos raised to power 2m minus 1 theta into sine raised to power 2n minus 1 into theta d theta will become cos. You can consider this like this one is, that is 1 minus integration 0 to pi by 2, 0 to 1, after replacing the limit in this substitution. In this substitution, if you consider theta as a 0, z will become 0. If you consider theta as a pi by 2, z will become 1. So limit will be changed. The cos will become 1 minus z, cos square will become 1 minus z raised to the power m minus 1 into z raised to the power n minus 1 into dz. How can write this one? I consider like this one, that is cos square, cos raised to power 2m minus 1 theta, sine raised to power 2n minus 1 theta, and d theta is 2, it is division of d theta will become dz divided by 2 sine theta cos theta, that will become cos 2m minus 2 theta into sine 2m 2n minus 2 theta d theta. So because this can be written as cos square theta raised to the power m minus 1, it is sine square theta raised to the power n minus 1 dz. Cos square is 1 minus z and sine square is z, and simply dz. So we can write the above term like this one, or by the symmetry of the gamma function, by the symmetry of the gamma function, or you can say by the definition of the gamma function, this will become definition of the gamma function, it will become beta of nm, beta of nm, but beta function is because of the symmetry, so it is equal to be beta mn. So from equation, substitute all the values in this one. It is gamma of m into gamma of n. So star, I mark this equation as a star. Therefore, substituting all these values, one is this. We consider equation number 1 and 2 only. Yeah. So we consider this equation as a 3 and this one as a 4. So using 3 and 4 in a star, using 3 and 4, 4 star becomes gamma of m into gamma of n is equal to be gamma of m plus n, gamma of m plus n into beta of mn. This implies beta of mn is equal to be gamma of m into gamma of n divided by gamma of m plus n. Hence prove the result. Hence the result, that is the relation between beta and gamma function. That is beta of mn is equal to be gamma of m into gamma of n divided by gamma of m plus n. Using this formula, we can also find the value of gamma of 1 by 2. Earlier we deduce gamma of 1 by 2 earlier also, and we can also evaluate the gamma function gamma of 1 by 2 from this relation also. That is value of, evaluate the value of gamma of 1 by 2 using this relation. Since beta mn is equal to be gamma of m into gamma of n divided by gamma of m plus n, therefore by consider m is also 1 by 2, n is also 1 by 2, because this relation is true for every positive value of mn. So it is also true for some particular value of mn which will be positive, that is 1 by 2. It will become gamma of 1 by 2 and gamma of 1 by 2 divided by gamma of 1 by 2 plus 1 by 2, that is 1. This implies beta of 1 by 2 is equal to be gamma of 1 by 2 का whole square, gamma of 1 by 2 का whole square divided by gamma of 1, which is equal to be 1, which is equal to be 1. This implies gamma of 1 by 2 whole square is equal to be beta of 1 by 2 1 by 2, because gamma of 1 is 1. Then apply the definition of the beta function in the right hand side. This implies gamma of 1 by 2 whole square is equal to be integration 0 to 1 x raised to the power 1 by 2 minus 1 minus x raised to the power 1 by 2 minus 1 dx, that is equal to be integration 0 to 1, that is 1 by 2 minus 1 is minus 1 by 2 in both 1. So you will get the integration for this dx divided by under the root of x into 1 minus x. Now to solve this particular type of the integral, we can consider, or by putting x is equal to be sine square theta. This implies dx is equal to be 2 sine theta cos theta d theta. So therefore above integral, that is gamma of 1 by 2 whole square, will become integration 0 to pi by 2. The limit also changed. If x is equal to 0, theta will become 0. If x is equal to 1, theta will become pi by 2. So we consider the limit will be changed 0 to pi by 2, and dx value of dx is 2 sine theta cos theta d theta, and value of x is sine square theta. It is 1 minus sine square theta under the root. That will be simplify 1 minus sine square theta, that is cos square theta, and under root of sine square theta into cos square theta will become simply sine theta cos theta, integration 0 to pi by 2, 2 sine theta cos theta d theta. In denominator also we have sine theta into cos theta. That is just simply twice of 0 to pi by 2, 1 d theta. Sin theta cancel with the sin theta, cos theta cancel with the cos theta. Just integration of 1 with respect to theta is theta. Integration you will get pi. This implies gamma function of 1 by 2 whole square is equal to be pi. That means gamma function of 1 by 2 is root pi. This is an alternate method using the relation between beta and gamma function. One method we have already defined. Now using this particular value gamma of 1 by 2, we can find some values of the gamma function. For example, gamma of 7 by 2, that is equal to be gamma of 7 by 2 is equal to be, we already consider it like this one, gamma of 5 by 2 plus 1. Using the recursion formula, it will become 5 by 2 into gamma of 5 by 2. Then it again apply the recursion formula. It will become 3 by 2 plus 1. It will become 5 by 2 into 3 by 2 gamma of 3 by 2. Again apply the recursion formula, that is 5 by 2 into 3 by 2 gamma of 1 by 2 plus 1. That will become 5 by 2 into 3 by 2 into 1 by 2 into gamma of 1 by 2. But gamma of 1 by 2 is root pi. So what you will get? You will get 5 3 ja 15, 2 2 ja 4, 2 ja 8. 8 root pi. This will be the value for gamma of 7 by 2. Gamma of 7 by 2. Similarly, the relation, similarly using these values, one can also find the value of beta for the fractional values, that is beta of 5 by 2 and 3 by 2, using the relation between beta and gamma function, that is gamma of 5 by 2 into gamma of 3 by 2 divided by gamma of 5 by 2 plus, we can consider the above value, so replace 5 by 2 with the 7 by 2, so that we can use the above values. 7 by 2, that is 7 by 2, 7 by 2 plus 3 by 2. In numerator, we can use the above value which I have already calculated, gamma of 7 by 2, and gamma of 3 by 2 can be evaluated. Gamma of 3 by 2 is this one. From here you can evaluate gamma of 3 by 2. From this part onward, any remaining of this value will be the gamma of 3 by 2. That means 1 by 2 into root pi. 1 by 2 into root pi is the value of gamma 3 by 2. That can be using here also. That can be using here also. It means gamma of 7 by 2 is 15 by 8 into root pi. Gamma of 3 by 2 is 1 by 2 into root pi. And in denominator we have gamma of 7 plus 3, 10 divided by 2, that is 5. Gamma of 5. And gamma of 5 will become factorial 4. Gamma of 5 will become factorial 4 using repeated recursion formula, that is 15 by 16 into pi divided by factorial 4. Factorial 4 means, that means 15. Now just simplify this value. 15 pi divided by 16 into 4 into 3 into 2 into 1. 16 into 16 is the first part. Then 16 4 ja 64 and 6 3 2 ja 6. and is 64 into 6 multiply. 6 4 are 24, 6 6 are 36, 38. That
Sir,
means
5 by 128.
अच्छा, 3 will be cancelled. Okay, okay.
Yes.
3 will be cancelled. 3 5 are 15. 3 will be cancelled. 5 divided by
128.
1 to 8 pi. 5 pi divided by 1 to 8 will be the value of beta 7 by 2 and 3 by 2. This will be the value for beta 7 by 2, 3 by 2. Similarly, one can find the other values of the beta function using these values. Similarly, one can find the other values of the beta function. This is for yourself, that is beta of 9 by 2 and 7 by 2 for yourself. Next, using the same type of the analogy which we have already discussed, that is consider the gamma relation between the beta and gamma function, we should evaluate one integral, that is evaluate this integral 0 to pi by 2 sine raised to the power px cos raised to the power qx dx. Sine raised to the power px into cos raised to the power qx dx. Let us evaluate this one. Solution. For evaluating this, we consider by putting some particular value for this value, the sine square x is equal to be t. This implies 2 sine x cos x dx is equal to be dt. Therefore, the above integral 0 to integral 0 to pi by 2 as substitute the value of sine square x is equal to t. So limit also changed. At the point of x is equal to 0, t will become 0. At x is equal to pi by 2, t will become 1. So limit also changed. For that, to make all the changes, we should rewrite the values of these so that we can use 2 sine theta cos theta dx in terms of the dt. 0 to pi by 2, it can be written as sine raised to the power p minus 1x cos raised to power q minus 1x into sine x cos x sine x cos x dx. That can also be rewrite like this one, 0 to pi by 2, that is sine square x raised to the power p minus 1 divided by 2 cos square cos square cos square raised to the power q minus 1 divided by 2 into sine x cos x dx. It is equal to be, after substituting all these values which we have considered here, that is sine square t is equal to this. Using this sine square t is equal to this, we can evaluate the values of the to 1. So limits also change, 0 to 1, 0 to 1. This can be written as t raised to the power p plus 1 divided by 2 minus 1. You can write p minus 1 divided by 2 as like this one. P plus 1 divided by 2 minus 1. Just simplify it. 2 as LCM. P plus 1 minus 2. That means P minus 1 divided by 2. Similarly, the Q minus 1, that is similarly Q minus 1 by 2 is also right as Q plus 1 divided by 2 minus 1. In left hand side, what we have? We have the integral which is to be evaluated. In left hand side. Therefore, in right hand side, it will become beta of p plus 1 divided by 2 and q plus 1 divided by 2 as per the definition of the beta function. As per the definition of beta function. 1 by 2 is also there because of this 2 sin x dx. Only we have the sin x cos x dx. So 2 is in the denominator, dt divided by 2. That is 1 by 2. 1 by 2 is also there. So then apply the relation between beta and gamma function. Then gamma of p plus 1 divided by 2, gamma of q plus 1 divided by 2 divided by 2 into gamma of p plus q plus 2 divided by 2. This will be the evaluation of the integral. This integral 0 to pi by 2 sin raised to the power px cos raised to the power qx dx. For example, for this in generalize for the particular value of the p and q, this integral is to be evaluated. Integral 0 to pi by 2 sin square theta cos की power 4 theta d theta, or d you can consider as a dx. That will become, that is p is equal to be 2 and q is equal to be 4. It will become gamma of 2 plus 1 divided by 2, gamma of 4 plus 1 divided by 2, twice of gamma of 2 plus 4 plus 2 divided by 2. That will become gamma of 3 by 2. We have already evaluated gamma of 3 by 2, and gamma of 5 by 2 is also evaluated and divided by gamma of 4 plus 2 6, 6 plus 2 8 divided by, that is gamma of 4. And gamma of 3 by 2 is 1 by 2 into gamma of 1 by 2, and gamma of 5 by 2 will become 3 by 2 into 1 by 2 into gamma of 1 by 2 divided by 2 into factorial 3, as the value of gamma 4 is factorial 3. It will become 1 by 2 into 3 by 4, 1 by 2, that is 3 by 8, 3 by 8. एक मिनट करी का फोन देखना. 3 by 8 into gamma of 1 by 2 का whole square divided by 1 divided by 2 into factorial 3 is 6. Factorial 3 is 6. Factorial 3 is 6. Gamma of 1 by 2 value is root pi. That is 3 2 ja 6, 2 2 ja 4. So it will become 8 4 ja 34. Gamma of 1 by 2 is root pi. That is pi divided by 32 will be the answer for this particular integral, that is integral 0 to pi by 2 sin square theta into cos square cos की power 4 theta. Similarly, one can evaluate the other values for the particular values of p and q. For the particular values of p and q, let us consider the remark for particular value of the for P is equal to be Q is equal to be 0. We have in this above integral the gamma of 1 by 2 whole square divided by 2 into gamma of 1 is equal to be integral 0 to pi by 2 sine raised to the power 0 1 cos raised to the power 0 1. It will become only the integration of this one, that is pi by 2. It means from here also you can find the value of gamma of 1 by 2. Gamma of 1 by 2 whole square will become 2 cancel with 2, that is pi. Hence gamma of 1 is equal to be 1. That means gamma of 1 by 2 is equal to be root pi. Any gamma of 1 by 2 can be evaluated by a different method. This is the third method from where you have evaluated the value of gamma of 1 by 2. Now let us remark 2 for some particular values of P and Q. For P is equal to be n and Q is equal to be 0. We get integration 0 to pi by 2 sine raised to the power n x dx will become gamma of n plus 1 divided by 2 into gamma of 1 by 2 divided by twice of gamma of n plus 2 divided by 2, and which will be evaluated as per the values of n, Similarly, integration 0 to pi by 2 cos raised to the power n dx will become the same value, that is gamma of n plus 1 divided by 2 into gamma of 1 by 2 have the particular value, that is root pi, can be replaced after that twice of gamma of n plus 2 divided by 2, and further can be evaluated using the particular whatever be the value of n. जो भी आपकी n की वैल्यू होगी वो इसमें पुट कर देंगे, उसी के अकॉर्डिंग हमारी गामा की वैल्यू आ जाएगी. दीज आर बिकम दी फॉर्मूला. जो आपने 12th क्लास में आपने डायरेक्ट फॉर्मूले पढ़े थे, एक्चुअली में वो फार्मूले यहाँ से डिराइव होके आते थे, जो आपने मेरे ख्याल से 2-3 दिन पहले भी आपने पूछा था कि इनकी वैल्यू क्या होगी, यानी 3/2 इंटू 1/2 इंटू रूट पाई लिया था हमने, वो इसलिए आया था. ठीक है. Now let us consider the question. Let us consider the questions on the basis of these. Let us consider the example on the basis of the formula derived earlier. Let us prove that integration 0 to infinity e raised to the power minus ax x raised to the power n minus 1 dx will becomes gamma of n divided by a raised to the power n, where a and n are positive. A and n are positive and reduce. Hence, deduce that integration 0 to infinity e raised to the power minus ax x raised to the power n minus 1 cos bx dx is equal to be gamma of n divided by r raised to power n into cos n theta, and second part to be deduced is integration 0 to infinity e raised to power minus ax x raised to the power n minus 1 sine bx dx is equal to be gamma of n divided by r raised to the power n into sine of n theta. These two are to be reduced after proving the first one, where r square is equal to be a square plus b square and theta is equal to be tangent inverse b by a. Tangent inverse b by a. Let us consider the solution for this. Let us consider the solution of the first part, which is to be prove. ये जो हमने प्रूव करना है, सबसे पहले हम इसको प्रूव करेंगे, फिर उसका यूज करके हमने ये डिड्यूस करने हैं. These two are to be deduced. ये दोनों डिड्यूस करने हैं हमने, लेकिन उससे पहले हमने ये प्रूव करना है. पहले हम इसका प्रूफ लेते हैं. फॉर प्रूविंग दिस वन, let us consider the particular value. Let ax is equal to be z. This implies dx is equal to be dz divided by a in the left hand side of the above integral. Integral of equation 1, we get this integral 0 to infinity e raised to power minus ax x raised to the power n minus 1 dx will become integration 0 to infinity. Limits are the same, as x will be 0, z will be 0, x will be infinity, z will also be infinity. E raised to power ax replaced with z, that is e raised to power minus z. Then z will be x will be z divided by a, z divided by a raised to the power n minus 1 into dz divided by a. That is equal to be 1 upon a raised to the power n, because we have a raised to power n minus 1 here and a also here. So it will become a raised to power n. Integration 0 to infinity e raised to the power minus z, z raised to the power n minus 1 dz, which will become the definition of the gamma function under the integral sign. We get the definition for the gamma function, and gamma of n divided by n, a raised to power n. This integral will become gamma of n divided by a raised to power n, which is required to be proved. जो हमें प्रूव करना था वो कर दिया फर्स्ट पार्ट, where a and n are positive, क्योंकि हमारे डेफिनेशन की गामा फंक्शन में ये पॉजिटिव वैल्यूज हैं. Now deduction of the first part. For deduction, replace a by a plus iota b, a by a plus iota b in the above integral, in both sides. We get, in left hand side will become e raised to power a, that will become integration 0 to infinity e raised to power minus a plus iota b into x raised to the power n minus 1 dx. In right hand side we have gamma of n divided by a plus iota b raised to the power n. Now as we just simplify the left hand side, that is e raised to power minus times of a plus iota ba into x can be written as e raised to power minus ax into e raised to power minus iota bx, that can be written as e raised to power minus ax into cos bx minus iota sine bx, because we have the formula for this one. E raised to power iota x is equal to be cos x minus iota bx. Using that formula, this term of the integral will become this one. And also putting a is equal to be r cos theta, b is equal to be r sine theta, as per the given condition, that is r, which implies r square is equal to be a square plus b square, and theta is equal to be tangent inverse b by a. Therefore, a plus iota b raised to the power n, which is in the denominator of the right hand side, will become r cos theta plus iota r sine theta raised to the power n. That can be simplified r raised to the power n into cos theta plus iota sine theta raised to power n, using the De Moivre's theorem, that is r raised to the power n into cos n theta plus iota sine n theta, by using De Moivre's theorem. Using De Moivre's theorem. Therefore, the integral 1, integral 1 in place of this, let it be integral star, mark as a star. Therefore, from star we have left hand side integral 0 to infinity e raised to the power minus ax into cos of bx minus iota sine of bx x raised to power n minus 1 dx is equal to gamma of n divided by r raised to the power n into cos n theta plus iota sine n theta, which can be written as, right hand side can be written as gamma of n divided by r raised to power n into cos of n theta plus iota sine of n theta raised to the power minus 1. Again apply the De Moivre's theorem. The right hand side will become gamma of n r raised to power n into cos of n theta minus iota sine of n theta. Now equating the real part and imaginary part of the both sides. In left hand side we have the under the integral sign, that will convert it into two parts. One part is a real part, another integral part is a imaginary part. So now equating the real and imaginary part on both sides. We have, in first part we have e raised to power minus x into cos bx. We have, that is real part is integration 0 to infinity e raised to the power minus ax into x raised to the power n minus 1 into x raised to power n minus 1 into cos of bx dx. This is the real part in the left hand side, and real part in the right hand side will become gamma of n divided by r ki power n into cos of n theta, and imaginary part of the left hand side will become 0 to infinity and e raised to power minus ax x raised to power n minus 1 into sine bx is equal to be, in right hand side we have gamma of n divided by r raised to the power n, gamma of n raised to power r raised to power n into sine theta, into sine n theta, which are the first and second part of the deductions of the deductions. Hence the result. Hence the result. तो इस तरह से हम इसको प्रूव कर सकते थे. First we have to prove this integral, and otherwise this integral is very difficult to evaluate, and this integral is very difficult to evaluate, but using the definition of the gamma function it can be evaluated easily. It means for evaluating this integral, first you have to prove this integral. This integral is equal to the gamma of n divided by a raised to power n. Then for deduction of this by particular values of a and b, because it is true for every value of a and b, either it is real number, real or complex. So we consider this a is a complex. That means replace a with a plus iota b. Then we can deduce all these values. Reduce all these values. Hence the result. इस तरह से आप रिजल्ट को कर सकते हैं. ठीक है, क्लास है भाई तुम्हारी?
Yes, sir.
Yes, sir.
चलो
Yes,
ठीक
sir.
है, ठीक है, ओके,
Thank you, sir.
ठीक है,
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
ठीक है, वेलकम वेलकम.